morning. I'm Donnie Tucker, and I'm performing a mock-up of a simulation of the new device I've designed. It's designed to set down on a pipe such as what we saw gushing oil in the Gulf in 2010. My unit is designed to set down rapidly on a flange like you saw the oil gushing from, and lock on and hold a great amount of pressure. The unit I'm using today is a simple unit. It's a homemade version. I'm using a belt material for seal.
This is just a piece of belt material.
Just to kind of prove a point, this is not a seal material at all. It's a piece of belt material. Okay. The pump here will produce over 10,000 psi. If I go over 10,000 psi, this gauge here, we're not using it. This gauge has done been blown. The pump has exceeded 10,000 pounds, and now the gauge will not zero out. It's damaged the gauge. But I have a brand new gauge over on the unit that we're testing. Let's move over and take a look at the unit we're testing. Okay, this is the very basic model of the Tucker flange lock that I designed, and it is very basic. This is crude. So I throw it together here under my shoulder. This is a pressure gauge capable of reading from 0 to 10,000 psi pressure. Here kind of simulates the illustration I have in my drawings that's posted on YouTube. This is a very basic housing. Underneath it simulates the plates that pull and hold the flange. There's a flange in here, similar to what you saw in the ocean. That right above it was the pipe was cut and the oil was gushing. Well, if you look down a little closer in that video, there was a perfect pair of flanges directly below it. My design is, this unit is designed to set down over those flanges and lock onto those flanges. The flange has a perfectly factory machined edge on it. Using that edge with great amounts of pressure, bolting this thing down with several bolts, it will lock on and create a seal, holding the oil in and the seawater out. I've used a rubber gasket material, a rubber belt material here today, just to prove what it would withstand. And this is not even a seal material. This is a belt material, never designed to be used as a seal. That's what I had on hand, and that's what I decided to use for my test material. With this basic mock-up, let's see what she can withstand. Hey, look, get behind something. See if that thing blows apart. Get behind something. That's 2,000 pounds, 2,000 pounds of pressure. Working on a rubber seal. I'm going to gradually bring it up. Get behind something, please, in case it blows apart. Bring it up. 3,000 pounds. That's 3,000 pounds on pressure. 3,000 pounds and gradually going up to 4,000. I'm taking it on up to 4,000 pounds. This is very dangerous. 4,000. She blew 5,000 pounds. That was on a rubber seal, folks. That was not what I desired. That is not the seal I want to use, but that was just a test model. I held 5,000 pounds with that rubber seal, which was not designed ever to be a seal. That is a piece of belt material. But it's just a simple test that shows that the design works with the proper seal in it. Had that been the actual model I designed with the metal soft ductile seal, I think you can read between the lines what we would have had here today. This was a simple rubber seal compressed in there, a piece of belt material, not even a seal material. It held right up to 5,000 psi of pressure before she blowed. That's a good test for what materials we used. Thank you very much.
This is just a piece of boat material.